Hi, welcome again. Today we will be covering these three topics of our roadmap. In our last video, we tried to understand that why SDL are so important for current generation digital system design. We learned how hardware description language can help designer in designing a system more effectively and that too in lesser time and very minimal errors. We take an example of simple multiplexer, so let's have a quick recall of that, how we describe the behavior of a multiplexer in SDL. We would describe the behavior as if input select is 0, then output gets the value of input A, else if input select is 1, then output gets the value of input B. And let's leave everything to the tool to design a system for this function. So as long as tools correctly implement this behavior, we really don't care what logical diagram tools created for us. We simply want a digital system that behaves like we described it to behave. So this was the basic idea behind hardware description language like VHDL and Verilog SDL. Here is a brief look for a background understanding of how early stage of digital system gets designed and how it is evolved to hardware description language. When we first started doing digital system design, we basically connect one transistor to another in a chip and combining them to create a logical gates like AND gate, OR gate, NOT gate, etc. And then we create a function. But at the time, the chips was not that complex and transistors inside a chip also very less. But still making a design was very time consuming and not that efficient due to high probability of errors. Another big problem was if because of some reason someone needs to modify the design, then it was too difficult. So when we grown to little more complex systems and when ASICs are getting more dense and complicated, we started using logical level design and we jumped from transistor level designs to logical level designs. Just a quick note, those who are not familiar with logical level design, then it's the schematic level design where we use this basic logical gates like AND gate, OR gate, NOT gate, etc. to design our digital system. But the problem was that because with time, density of the logical gates and transistors grew very fast and ASIC grows too. So designing modifications and corrections sometimes gets unmanageable. Just assume in today's time when we are developing chips on 3 nanometer technology with billions of transistors inside a single chip and having hundreds and thousands pages of logical level design and schematics sound impossible to design, right? And yes, that's even true. If we would stick to just transistor level design or logical level design, we cannot even think of that. So this is where the concept of hardware description language comes in and make it possible to describe behaviors of digital systems. And our tools do the job of synthesizing and create the logic level schematics for us. And because these tools are designed to do that job of synthesizing, they do it more effectively and allow maintainability of complex systems as well. And by the time when FPGA gets available, these tools become life-saving. And we started using hardware description languages today for digital system design. So why hardware description language is needed? You can say we are able to create complex system designs with high gate counts and that's too in lesser time. Your designs will be more efficient. You can design your digital system with fewer bugs, allow flexibility of easy modification and correction, reduces cost. Since engineering time and design contributes a major part in chip designing, it significantly reduces the cost and the time as well. Let's explore VHDL in brief. So VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. I know it's quite long, but it is. VHDL is defining hardware. This is a high-level language, which means it is written in text form, and this makes it easy to read and understand, likewise other programming languages we have. Good thing about VHDL is there are many tool vendors who supports it for simulation and synthesis. That means you have the flexibility to choose. A quick history: VHDL introduced by US government project as integrated circuit simulation tool initially, but later it starts with digital system design. VHDL receives multiple standard revisions, started as IEEE standards 1076 in year 1987. The most significant release was in year 1993 and that is still being used. Later revisions were in year 2006 and 2008 with some nice to have features as well. This is important to know that VHDL design is not a software programming language. Although you can say that it looks very similar to C language or any other software programming language, you may say it's a sequential language too, like other programming languages, but this may take little time to accept that VHDL is not a software programming language. But let me tell you this thing, that VHDL is a design language that is describing the behavior of what you wanted to get from your digital system, and the tools do the job of translating that description into the semantic logic and FPGA mapping. And let me tell you one more thing, that VHDL not only allows the sequential statement for execution, but it also allows the parallel execution of statements as well, which we will learn later. VHDL versus Verilog SDL. Well, the fact is that both the languages are not much different with each other compared to their similarities. First thing is, both VHDL and Verilog SDL almost do the same job of describing the hardware and create digital system design with semantics and logical design. The main difference is syntax related. Some says VHDL is little more difficult to learn compared to Verilog SDL and require little more text to write, which is little bit true, but that helps you sometimes to figure out the errors more conveniently at compilation stage. So it's a trade-off. And the good thing for you is that once you learn the VHDL, Verilog SDL will be simple to learn then, and Maxim tools understand both VHDL and Verilog SDL. But the fact is, eventually you need to learn both VHDL and Verilog SDL because many chip projects uses combined design of VHDL and Verilog SDL. If you found this video helpful, please give it a like and leave a comment below, and don't forget to subscribe for regular updates.